This chapter 14, we're going to be talking all about waves. And specifically, we're going to talk about sine waves and cosine waves. The most common experience that we have with these types of waves, sine and cosine waves, are something like sound waves. So when you're listening to music, you're actually hearing these sound waves being transmitted like this, that little packets of information that keep going up and down and up and down that are getting to your ear. Based on the volume, it'll change, how the wave looks. Based on what type of music it is or how it sounds, it changes how the wave looks. But that's how the information is being transmitted to you, to your ear. Now, we're going to we're going to look at the most basic example of a sine wave, or y equals sine theta. And y equals sine theta looks just like this. It starts at 0, because if you put in a 0 for theta or x, we could also call this graph y equals sine x. So we do sine 0, we're going to have 0. So at 0, y is also 0. When we go to pi over 2, remember that's 90 degrees, pi over 2. Sine of pi over 2, or 90 degrees. It just depends what mode you're in. Okay, we're in degree mode. Let's put it in radian mode. So sine of pi over 2 is going to be 1. So when x, or theta, is pi over 2, or 90 degrees, the sine of that is 1. That's why the graph's up here. The sine of pi, so sine of 180 degrees, or the sine of pi, is back to 0. The sine of 3 pi over 2 is down to -1, and the sine of 2 pi is back to 0. And this will just repeat on and on and on, just like this. Just like we see up in the sound wave, this packet of information will just keep going and going and going. We can draw this on forever and ever and ever, as long as we're increasing it by 90 degrees each time. There are a couple key features of this graph that we need to point out. The first thing is the graph's period, which for the graph of y equals sine theta, or y equals sine x, the period is 2 pi. And what the period is exactly how long it takes this thing to complete one cycle. So if we kept drawing this, it would do something like that. And that just repeats what we started with over here. So this one cycle is how long one period is the distance, or how long it takes it to get back to where it started, to where it would just start repeating itself. So the period for y equals sine theta is equal to 2 pi. And that's the time it takes, or yeah, we can think about it as time, it takes to complete one cycle to get back to where it started. The next thing you need to know about is the amplitude. And the amplitude is half the distance from the top of the graph, the very peak, to the bottom of the graph. That's very important to remember, because sometimes this graph will be shifted up or shifted down. It's not just the distance from the top to the middle or the bottom to the middle. It's half the total height of the entire thing. So in this case, the amplitude is 1. Because it's 1 from here to here, and 1 from here to here, so half of 2 is 1. The amplitude is 1. Yeah. I should also note that the domain for any of these graphs, so the graph of y equals sine theta or the graph of y equals cosine theta, the domain is all real numbers. It actually goes to the left as well. Remember, you can put in negative angles as well, like negative pi over 2. It'll keep going to the left, like negative pi. You just draw an angle in the opposite direction. It'll give you the same thing. So all real numbers. And the range is going to be the distance from the top to the bottom. So the range is -1 is less than or equal to y, less than or equal to 1. Because it can be -1, and it can be 1, and everything in between. So it's capped at -1 and 1, but it can also be those. That's why we have the equal to as well. Now, just like with other types of graphs, y equals sine x is the most basic form, but we can change it a bit if we put an a in front and then put a b in front of the x. And what those are going to affect is the amplitude, so the half the distance from the top to the bottom, and the period, how long it takes it to complete one cycle, how long it takes it to start over. So this part needs to go in your notebook. The amplitude is equal to the absolute value of a. So sometimes, like if you see y equals sine x, it doesn't have a number in front, so that you can assume that a number is 1. So actually, amplitude would be equal to the absolute value of 1, which is 1. If you had something like y equals 2 sine x, the amplitude is equal to the absolute value of 2, which is 2. The absolute value is just reminding you, if you have something like negative 1/4 sine x, the absolute value of negative 1/4 equals 1/4. So the amplitude, or a, would be equal to 1/4. The same thing's true when you're talking about the period. So normally y equals sine x, it doesn't look like it has an a or a b, but actually there's a little 1 there. We can think of the b being 1. So the period of the normal graph, like we already know, is 2 pi divided by the absolute value of 1, which is just 2 pi. If we have something like y equals sine 3x, well, to find the period, you would do 2 pi divided by the absolute value of 3, which is 3. So the new period is 2 pi over 3, which is pretty interesting because in the normal one, in the normal graph, 2 pi, it means it takes it 2 pi, or that's, like that, like the entire 2 pi, or you can think about it, it'll take it the entire way around the circle to complete one period. But if you increase this number, it actually shortens it, because now it only takes it 2 pi over 3. That's 120 degrees. So it only takes it, it takes it much less time to complete the period, or it'll complete the whole thing by 120 degrees. It takes it less time if this number is higher. In order to graph any sine function, so that's a sine bx, like we have here, you need to find these 5 key points, and that'll help you graph each one. So for sine function, you graph these 5 key points. You graph 3 x-intercepts, you graph the maximum value, and you graph a minimum value. So 3 x-intercepts, a max, and a min. So 3 x-intercepts, 1 max, and 1 min. And you're just going to use the formulas that it tells you here. The first x-intercept is at 0, 0. The next one is 1/2 times 2 pi divided by whatever b is, comma 0. The third one's 2 pi over b, comma 0. To find the max and the min, there are also some equations there. So I'm going to show you how to graph y equals 4 times sine x. The first thing you do is find out what the amplitude is. So we'll just say the amplitude equals the absolute value of 4, which is 4. We also need to know what the period is. So the period is equal to 2 pi divided by the absolute value of b, which here there's no b, so it's just 1, which is equal to 2 pi. So in some cases the period will be different, but in this case it's just 2 pi. And all that's saying is here, if you notice, 2 pi divided by b, that is the period. So once you know the period, you can just plug that into those spots. And that's going to make it a lot easier for you. But let's go ahead and find some points. So the first intercept is at 0, 0, so we're just going to put a dot there. 0, comma 0. We know the graph's amplitude is 4, so that means it's going to go all the way up to 4. And down to 4, down to negative 4. The second x-intercept will be calculated by the formula 1/2 times the period, which is 2 pi. That's the x value. And the second value is going to be amplitude, which is 4. And I'm just getting that, second value is just 0. And I'm just getting that directly from here. So 1/2 times 2 pi, that's pi, comma, 0. So if this is pi over 2, this is pi, 3 pi over 2, 2 pi. We're going to have a dot at pi, comma 0, so go over pi and then stop. That's the second point. The third point is going to be here, the period, comma 0. And here the period is 2 pi, so go over to 2 pi, comma 0. So those are the three x-intercepts. Now we just have two more points to plot. The first one is going to be the height, so 1/4 times the period, comma a. So 1/4 times 2 pi, comma the amplitude, which is 4. So that's 2 over 4, that's 1/2 pi, or pi over 2, comma 4. So I'm going to write pi over 2, comma 4. So go over to pi over 2 and up to 4, put a dot. And the minimum is going to be 3/4 times the period, 2 pi, or 2 pi over b, I should say, and negative amplitude, so negative 4. So we're going to have 6 pi over 4, comma negative 4, which is 3 pi over 2, negative 4. So we go over to 3 pi over 2 and down to negative 4, and we put a dot. The last step will just be connecting the dots. And that's going to be our sine wave. And it's going to continue on like that forever in the positive and negative